Hello everybody. In today's tutorial, we are going to be creating flower or plant-like structures in TouchDesigner, all within the built-in modeling tools. So let's start. Yeah, this technique should be able to be applied to a lot of other natural things. Basically, we're going to be creating one petal or leaf type structure. You could use the same technique to make petals, leaves, whatever you want, and then duplicating it around a bunch and then texturing it, applying materials on it. And yeah, we're just going to go ahead and get started. We are in a default TouchDesigner file. We're going to delete everything and we're going to start with a line. So this line, we are going to basically deform the points, move them, and then flip that, mesh it together, and that's how we're going to create our leaf. So in order to do that, we need some data, which we're going to get from a pattern. We can just leave it at this for now. We're going to connect this to a chop to, put this to a null, and we're going to get our data from this null. So basically what's happening here, you'll see by default, you get this exclamation point. If you middle mouse, you can look at the information and you can see that says channel T, X, T, Y, T, Z have not been found. You can also get that from here, right here. Basically what this is saying is that we're going to take this information in channel scope and map it to this information in attribute scope. So the channel scope is referring to stuff within here, and the attribute scope is referring to the geometry attributes in here, which by default is set to the position. If you go down here, you get to see a bunch of other attributes, but we're worried about the position because we want to move the position based off of this data. So right now we have this channel called channel 1, but we actually want to, I'm going to rename this to shape. And so now we have it called shape. Put this in here. We're going to get another error. More attribute values than channel specified. Extra attributes will have default unchanged value. Basically, if you look in here, we have 1,000 data points along here. And if you look here, we have 2 data points. We visualize here on the line. We have 2 points. So we need these to match. So back up with you. We're going to get a constant. And I'm actually just going to move this down here. I think it'll be less in the way. I'm going to call this segments. Let's call it segs. Connect this to a null. And we're going to put this to there as a chop reference. And also to the length of this pattern as a chop reference. And now there's nothing, but if we increase this, right, because we are mapping one attribute to too many attributes. So we need to map the shape to the P0, 1, and 2, which are like the X, Y, and Z. So we're getting this value and we're mapping it to the position of Z, X, Y, Z, which is 2. So if you see here on this line, now we have a shape of this pattern. So what that means is now anything that we put into here is going to become the shape of this line. So what I'd like to do is if you put a ramp, which just creates a straight a straight line, and then you put the Y taper to 0, you get a shape that looks like this. So a bit more leafy, as you could say. And you can also mix with this and put it to out here. If you hit this reverse button, it means you'll now have it centered around the origin. So now if we take a copy, 2 copies, and we're gonna scale it, we're gonna flip it. So we're gonna flip it around the Z-axis by scaling it by -1. So now we have like a shape that looks like, you know, leaf, petal, or whatever. Now we add you can either add a skin, and if you press W, you can look at the wireframe, or you can add a poly patch. And by default, the poly patch has more. If you change these resolutions, it'll like, you know, you have a bit more control over the like resolution of your geometry. And also if you come in here and change the segments, that also affects that. So I prefer to use the poly patch. I don't know, maybe you can do the same thing in the skin, but I feel like there's more control in here. So we have a leaf. We're going to add an attribute create, which will create normals. And we're also going to texture this, give it UV coordinates basically. And you can't notice anything. So what we're going to do is we will add a render setup. So we're going to put this to a null. From this null, drag a geometry component. So now we have a leaf. Add a light. Add a camera. Lights, camera, and action. Put this to a transform. Put this to a null. Look at the null. From the transform, also light. The light is currently placed like right parallel to this, so it doesn't have any, you can't actually see it. So now you move the light so you can see it. And then we can like zoom in on our leaf. And we can go to the transform, put the alpha to 1, comp over background color, you know, make this, I don't know, something like that. So yeah, now we have our leaf and we want to texture this. So let's add a material, drag the material to the geometry, add a noise, drag this to a null, drag this to the diffuse map, and you will now see that our leaf is textured based off of this texture node that we created. So if this texture node, if you bypass it, you can't have anything. And right now its projection is the Z-axis, which is this way. You want to project it from the Y-axis, which is up and down. So that means that it can be like that, or you could also do it this way, which is, but for this case, we would like it for the Y. And so now this is basically how you would like texture an object if you wanted to make this like not look like that, you know. Up the period a lot, has a bit more colors. You can add a lookup and a ramp. Set these to like some leafy colors. Yeah. So we have our leaf here. Let's up the resolution a bit. Now we can say we want to make it look more like this flower petal. You would basically mess around with the settings in here. So some settings to mess around with is this taper decay rate, which sort of makes it like this, more different. You could do amplitude. Just, you know, messing around with stuff. In this case, let's see. Just like a bit. Let's not reverse it. And then let's not do that. You can sometimes get some interesting results messing around with like the rounding of it, you know, because it like snaps to like integer values, but we want it to be smooth, so we're not going to mess around with that. Not reverse it. Let's see. Yeah, for now this works. And so basically this shape here is what is determining the shape of here. So everything we do to this, we can edit the shape. That means if we want to say add some noise or something, we could basically take a noise, put this to a resample, not that, put this into the bottom one. So now we have 30 samples in this, because by default the noise has like 600. It's based off of the sample rate here. But we want this to be the same as our segments here. So we just resample it based off of here. And so now if we take a math and we add these together and combine chops, add, now okay, so what happened is it's complaining about channel shape not found. So we need to, what happens if we switch these? Okay, just switch the orders around. Like this, yeah. So now we are basically distorting the image. So this noise is a bit much. we move the amplitude to 0, we don't get anything. If we just go up a little baby steps, get a little bit of variation, which, you know, depends on that, how many segments you have, you know, up the resolution, you have a bit more resolution to play with. But all this happens on the CPU, so don't get too crazy. You can mess with the roughness, which will, you know, depend on how smooth you want. Period of the noise, you want big noise, little noise. So yeah, let's say we got something like this. Let's just stick with that. I'm gonna take all this and just move it here because we're gonna go ahead and get to twisting. So if you want to add, also let's go ahead and get a split view and turn him into a geometry viewer. Okay. So there's different things you can do. For example, you can twist, you know, if you want to put a little twist in it. If you want to bend, which is what we want to do, is we want to bend this. But like, I don't know why it doesn't work this way, but you can, if you change it to this, YX, it will bend this way. And you can just like experiment, like, because every way you bend it, you get different results. Say you want to bend it like this way, and this roll off basically changes the position of that bend. So now, you know, bends around like, but we want to bend it this way, bit more flower like, not too much. And now we can adjust this roll off to be something like this. Now we can always say like, maybe we want to get the pattern and maybe we want to reverse it. Maybe we do want it like this way, you know? Maybe we want to change the amplitude in a little bit, because all of these decisions build upon each other. So the twist is very useful. I'm not gonna do any more, but like the linear taper is very good. The twist is cool. The bend is cool. The shear does weird things, and squash and squash do weird things. But like, if you just want to like get wild with your geometry, go crazy. So now we have this leaf petal, and we want to make it look like a flower. So you can either do instancing or you can use a copy swap. So let's basically see. So let's take the copy swap. You want a, okay, flower. I love you. You're just always in the way. And if we put it to there, we have a circle of flowers. Just a giant circle of petals. It's not a flower yet. I guess that's what a flower is a circle of petals. So we can move the orientation to be around this way, but I'm just gonna leave it right here for now, because if we copy this, they get placed on the normals of this object. So if we display the normals with P or right click, display options, P, they're gonna get put on this normal. So as you can see, if we match our axes, we got the Z here, the leaves are getting like put facing this way. We want them to face outwards so that we can have them all. So we basically want to rotate these normals outwards. So how to do that basically is you take a point top and you add normal, go down here, change this to input point dot x, change this to input point dot y, and change this to 0. And now you will see, if we look at here, actually what we're just gonna do is we're just gonna insert a null to make this easier, and just change the settings for you to show normals. So now you can see our normals used to be facing like here. Now they're facing outwards. It's basically just telling it that go to the vector at that position and 0. So now what does this mean? If we go to this circle, you also can add a facet, and that will, and if you go to make normals unit length, but actually connect that to there, sometimes the normals will not be correctly sized, and that can, like, it'll normalize them. So we go to the circle and we, you know, make this a bit more, I don't know. All right. You're gonna want to transform this after, wait, after you mess with the points. Because if you try to put this on the ZX plane like you want it to be, like on horizontally, then the normals just get like messed up. Even like, and you can't, like, I don't know, this with this like little equation thing doesn't work properly. So you have to like leave it here and then transform it. If you want to make it horizontal, just rotate it that way. So now we have something like this. We want to now add a transform in front of the pedal. And let's see. We rotate it this way. Now we can make our circle smaller, and we get something more like you would expect. So you could do something like this. In this case, this flower, I mean, I said I was gonna make this flower, but you know, this is like a new flower that was just like born today. So it's just cool. Go with this flower. So it's very uniform. I'm not really sure if there's a way to like scale based off attributes. Also, the other way to do this is to, there's two ways of doing this. You could also take your pedal and if you put this into, you can do instancing. So if you put this into a geometry, and let's just do it this way. We just do instancing, and then we do SOP2. Which is getting the geometry from, by default, it's getting the position geometry from this. You can change it to get like other stuff. You want the normals, if you want the UVs, which this doesn't have apparently, or something. I don't know. You drag that to there. Now if you put the TX to the TY to the TZ, and if you go to the next instancing tab and put rotate to vector, rotate to vector, rotate to vector, which is basically just like so I think the transforms are probably like I don't know, different. So yeah, this way we just want to rotate it. Also this one, let's just move him like right there. Yeah, so the transforms are a bit different, but these are two ways. You could either do it copy or you could do it for the geometry. The reason I like to do it through the copy is because if I want to actually edit this geometry after the fact, say like I wanted to add a noise, I'll also show you how to like pin the group so that not everything it moves wild, so you have more control over it. If I wanted to do something like this, you can't really do this out of the geometry because what comes out of the geometry comp is just like what you put into it, you know? And when you're instancing it, I don't think there's really a way to get the instance data out of there and then do more SOP level stuff out of it. I don't know if there's ways to do that or if it just would be too powerful or, you know, because it's on the CPU. I don't know what the architecture is like. So that's why for stuff like this, I like to use the copy SOP because then I can still do other stuff after the fact. And then if I wanted to, I could like instant these on a bunch of particles and, you know, go wild. So in order to get these groups pinned, let's go to a group. And we're going to call this group pin. We're going to make it a point group. And if we come in here, zoom in a bit, create bounds. So now the group is basically everything within this box. You see the yellow group is in the group, and we can, you know, change the size of this group. And right now we're saying the pin group. In the noise, there's a spot for pin. Wait, actually, so now it's basically, it's only working in the pin area. We want to flip this. I actually don't know. Does this work? Oh, it does work. So you can just like do like not pin and then if I make this bigger. Okay, that actually didn't work. I was like, okay, this is not Houdini. It's like they used to be here, used to be, but not anymore. So it doesn't work. So what we need to do is the way that I was doing it, which is we want to create a group in the same group called win that is not pin. So now if you see, this has been switched. And if you look, you have a group called pin and you have a group called wind. We go here and select wind. Now it's not doing it in the places with the wind. So it's a bit aggressive. Let's make you a bit smaller. That way, and then something like that. And then we change the settings on here. be a bit more relaxed. So yeah, from this point, if you wanted to take it and now you have this render, you could really do whatever you want with it. You could change the camera angles. If you want to get like some shots like this, you could you know change the pattern. Probably in small amounts is best. Stuff like that. If you want to make it more like it's more like a fern type of thing going on here. Then you can also, if you want to, you know, control some of these parameters, you could say num, I don't know, just call them petals, even though like you can use it for other stuff. And then you could come to here, export that to here. Now you have a control over this. You could do all sorts of stuff. You could, animate some of these parameters, like just all the control is here. So now, um, yeah, I'd say that's probably about all that I want to show you. Hopefully that gets you going with some ideas on how you could approach modeling more natural plants and things in TouchDesigner. This is only the beginning. Of course, you can take what you modeled and throw them into things such as feedback loops, as you're seeing here, or just do whatever else you want with them. Render them however you feel, play with them, and you could, have them be interactive if you wanted to make them interact with audio. Maybe that's something that I'll explore soon. It's definitely something I'll explore soon. So if you're interested, I'll definitely post something about that in the coming moments. So yeah, hopefully you enjoyed. Let me know if there's anything else you think I should explore, or if you found any better ways of doing some of the things that I did here. But yeah, you have a good rest of your day, and thanks for tuning in.